this, you're going to see these tables. Ice tables have not changed since I took this course in high school, and it just follows us for the rest of the course. So an ice table. Ice stands for three things. First one is, whoops, don't write in white on a white sheet. The initial concentrations, conditions, I guess we'll put conditions. C is the changes as system goes to equilibrium. And E is the equilibrium conditions. I'm hesitant to say concentrations because they're not always given to you in concentrations. So it's initially what you have. C is the change. So there's going to be some sort of addition or subtraction there. And then E is what happens at equilibrium. So the most basic kind, we have A breaks apart in a decomp reaction to B plus C. They're not solids and liquids, so we can use them in a KEQ. Initially, we have 2 moles of A, 1 mole of C, and they are placed in a 1 liter container. That's important because that'll be concentration, moles per liter. So initially, we have 2 moles of A. We have no moles of B, and we have 1 mole of C. I still don't have to put moles. When we get to equilibrium, okay, we have 0.5 moles of A left. What is the KEQ for this system? That's all you get. Okay, so if we started with 2 moles of A and we finished with 0.5 moles of A, what was the change? Negative 1.5, right? We lost 1.5 moles. Mm-hmm. So we lost 1.5 moles. If we lost 1.5 moles of A, that became B and C, right? How many moles of B did we gain? Sorry? 1.5. It's a 1-to-1 relationship. For every mole of A, you gain 1 mole of B and 1 mole of C. So we gained 1.5. How many moles of C did we gain? So at equilibrium, we have 0.5 moles of A. How many moles of B? 1.5. How many moles of C? 2.5. Okay, so you have to just do a tiny bit of thinking here. I know, this is probably the wrong time to be asking for thinking after that Math 100 test for some of you. Okay, what's the KEQ formula for this reaction? Expression. So products, so it's concentration of B over concentration of C over concentration of A. And there's no coefficients, so we're fine. Now, this question is straightforward because it's a 1 liter container, all right? So these are all the same as concentration, right? Moles per liter is concentration. So if you're in a 1 liter container, the moles is the concentration. So we can just use those numbers directly. So B is 1.5, C is 2.5, and A is 0.5. So you plug that into your expression and you get 7.5. Okay. Are we good? All right. So you know what the next step is. We're going to change the volume of the container, and we're going to make it a non-one-to-one reaction. Don't worry, we're going to keep it light today. This is all we're going to do. Okay, so we have a 4-liter container. All right. Our reaction is 2 moles of sulfur dioxide plus oxygen goes to 2 moles of sulfur trioxide. Initially, we have 0.5 moles of SO2 and 0.5 moles of oxygen are placed in a 4-liter container. So we have 0.5 moles of SO2. We have 0.5 moles of O2 and nothing of SO3. 0. Okay. When we get to equilibrium, we only have 0.1 moles of SO2 left. So how did we get from 0.5 to 0.1? We lost 0.4. Perfect. So let's look at sulfur trioxide. How many moles of SO3 did we gain? If we lost 0.4 moles of this, how many moles of this did we gain? 0.4, because it's a 1-to-1, right? How many moles of oxygen did we lose? 0.2, because this is a 2-to-1. For every 2 moles of SO2, we use 1 mole of oxygen. So if we use 0.4, we use half of that, so we lose 0.2. So at equilibrium, how many moles of oxygen are there? 0.3. And sulfur trioxide, we have 0.4. Now this is moles, but we know the KEQ expression has to be in concentration, which is moles per liter. So sort of the extra step here would be, what are the concentrations of these? We can just do it right in the table. It's a 4-liter container, so what do? Divide them all by 4. So the concentrations become 0.025 molar, 0.075 molar, and 0.1 molar. Then we write our KEQ expression, which is the concentration of SO3 squared divided by the concentration of O2 divided by concentration of SO2 squared. And then just plug in your numbers. Two 2.1 times 10 to the 2 or 210. That's the basics of an ice table. Okay? So you just have to do a bit of thinking, watch the ratio of the balanced equation. Again, another reason you need a balanced equation. Then you can figure out how many moles you've lost or gained. Write out the KEQ expression. Be careful if it's not a 1-liter container, you're going to have to do the conversion into concentration before you plug it into your KEQ expression. Okay? Are there any questions about that? All right, you can now do every question in there. I will warn you, question 1 through 7 are just like setting up the KEQ expression and stuff. They already fill in the blanks. Questions 8, 9, and well, 8 to whatever. 8 to 11 are more like what you'd see on a test. So if you want to ease your way into it, start with questions 1 through 7. If you want to just jump into the deep end, go 8 through 11. 8 to 11 are the more test-like questions. That's all we're going to do today. The Math 100 people can chill. If you're not in Math 100, you can just enjoy the relaxing Friday afternoon. But remember, your test is on Thursday next week.